Good day, students. Welcome to part 2 of the compass test for algebra. We're going to be going over sample questions 9 to 16. All right, let's go ahead and take a look at question number 9. It says, if 2 times the quantity x minus 5 equals negative 11, then x is what? So this is a solving equations problem. So let's go ahead and do it. So we have 2 times x minus 5 equals negative 11. Now there are two moves we can make here. One will be much more effective than the other. The first move we can make is divide both sides by 2. That will introduce a fraction, and then we can add 5 to both sides. But another approach we can use is we can distribute 2 first and then isolate x. Alright, so I think the second method is much more convenient because we won't have to deal with fractions until the end. Alright, so what I'm going to do is distribute first. Distribute 2 to x and 5. So 2 times x is 2x, 2 times 5 is 10, equals negative 11. Now I'm going to proceed to isolate x. So doing reverse PEMDAS, we have to add and subtract first before we divide, right? So I'm going to add 10 to both sides. And then I'll have 2x equals negative 1. And divide both sides by 2. And then my final answer is x equals negative 1/2. So the answer to number 9 is E. Okay? Alright, let's move on to question number 10. It says if 4 over 5 plus negative 3 over 10 equals x plus 1.5, then x is what? Alright, so let's go ahead and do this. 4 over 5 plus negative 3 over 10 equals x plus 1.5. Alright, so whenever you have two signs here, you just multiply the signs. Remember, plus times plus. If you multiply plus times plus, you get plus. Minus times plus, you get minus. Plus times minus, you get minus. And then minus times minus, you get plus. Bottom line is when you multiply different signs, you always have a negative. If you multiply the same signs, you always end up with a positive, alright? So these two signs are different, so when I multiply them, I'm going to end up with a negative, alright? So I'll have 4 over 5 minus 3 over 10, okay, equals x plus 1.5. Alright, now to find the LCD of these two, I'll times this by 2 top and bottom. And then we're going to have 8 over 10 minus 3 over 10, okay? The goal is to make the denominators the same so I can combine them. That's why I look for the LCD. The LCD of 5 and 10 is 10, right? So I just multiply by 2 top and bottom here so that I have the same denominator, right? So now that the denominators match, I'll just combine the denominators into 1 and then apply this operation to the numerators, alright? So 8 minus 3 is 5. 5 over 10 equals x plus 1.5. Okay, let me write that again. X plus 1.5. Alright, now we can proceed to see if we can simplify this fraction, 5 over 10. Since 5 goes into 10 in itself, I can divide this top and bottom by 5. If I reduce this, divide this by 5. Divide by 5 and divide by 5. That's the greatest common factor. If I divide by the greatest common factor, I'll end up with 1 over 2 equals x plus 1.5. Alright? So using the reflexive property of equality, I can switch my equation around, and I'm going to have x plus 1.5 equals 1/2. And then to get x by itself, I just get rid of 1.5 by using the opposite operation. Since this is plus, I'll subtract 1.5 from both sides. And I'll end up with x equals, signs are different, so I'll subtract and keep the sign of the bigger one. When I subtract, the halves cancel out, so I end up with negative 1. Okay? Alright, so your answer is x equals negative 1. So the answer to number 10 is C. Alright, let's move on to question 11. It says, for all non-zero values of r, t, and z, what is the value of this expression? So we have 16, r to the third, t, z to the fifth, over negative 4, r, t to the third, z to the second. A good strategy to use here is whenever you don't have any degrees on a variable, you put a 1. Okay, that's a default degree. So t doesn't have a power, so I put a 1. R doesn't have a power, so I'll insert a 1, okay? Alright, so let's deal with the numbers first. What is 16 divided by negative 4? 16 divided by negative 4 is just negative 4, so we have negative 4. Alright, now let's deal with the variables. Now this is a trick you can use. Just always subtract the lower power from the bigger power whenever you're dividing. Remember the law of exponents, x over a divided by x over b equals x over a minus b, alright? I always like to subtract the smaller one from the bigger one so I don't have to reciprocate after I'm applying this rule. Okay, so for the r's, which one is bigger? R to the third is bigger, so the numerator wins, r to the third. I'm going to subtract the denominator, which is 1, r to the 1. Okay? And then if you look at the t's, which is bigger, the denominator is bigger, so t to the denominator, t to the third, minus the numerator, okay? The denominator wins because the power here is bigger than the power there. For the z's, the numerator has a bigger power, so we're going to keep it on top and subtract the bigger one, 5, from the smaller exponents, okay? So notice I'm just subtracting exponents, the smaller from the bigger, smaller from the bigger, smaller from the bigger, alright? So you end up with negative 4 r squared z to the third divided by t squared. And there goes your final answer. Answer to number 11 is B. Alright, let's move on to question 12. It says for all values x greater than 0 and y greater than 0, there's this radical expression, the square root of x divided by 3 root x minus root y is equivalent to what? So anytime you want to get rid of radical expressions in the denominator, you just multiply by the conjugate, okay? You get the conjugate by simply inverting the middle sign. Alright? So I'm going to multiply the top by 3 root x plus y, root y, divided by the denominator 3 root x minus root y, plus. Okay? How on earth did I get this? All I just did is I took this denominator and I switched the middle sign. I took the opposite of the middle sign to create this. Okay? If this were a plus, that would be minus, minus. Since this is minus, the opposite is plus, plus, alright? The reason for this is because whenever you multiply a difference of squares, a plus b times a minus b, notice the difference here is this is a plus and that's a minus. You end up with a difference of squares, a squared minus b squared. And since these two quantities are being squared, that eliminates the square root from the denominator for sure. Alright, so this whole strategy is dependent on the difference of squares formula. Alright? So that's what we're going to do here. I'm not going to use this formula. I'm going to work out the whole process so you really see what's going on. In the numerator, we're going to be doing the square root of x times. We're going to be multiplying that by, well, let me write it this way so you don't get confused. 3 root x plus root y. And then in the denominator, we're going to have 3 root x minus root y times 3 root x plus root y. Okay? Alright, on the top we just distribute. If we distribute, we're going to have 3 root x squared plus root xy. Notice, whenever you're multiplying radicals, you just multiply the radicands, okay? And that's how you do it. And then if they have anything on the outside, any factor on the outside, you just multiply those factors also. Alright, divided by, now the bottom is going to be a little bit bigger, I'm sorry, a little bit longer than the numerator, okay? Alright, so we're going to multiply it out. You can call it FOIL or double distribution, whatever terminology you like. I'm going to do the first, outer, and then I'm going to do inner, then last, okay? Alright, let's do this. If we do the first, 3 times 3 is 9. Root x times root x is root x squared. And then if I do first outer, it's going to be plus 3 root xy. And then inner, minus 3 stays on the outside, root xy. And then last, minus times the plus is a minus, root y times root y squared. Okay? Remember, if you take the square root of a square, those are inverse operations, so they cancel out. So on the top, the square root and this square cancel out. In the denominator, the square and the square cancel out here. Likewise here. Okay? Alright, so in the numerator, I'm going to have 3x plus root xy divided by, in the denominator, notice what's happening here though. You have two opposites. These two terms are opposites of each other. Whenever I combine opposites, they add up to 0. Okay? So, and then you're going to have 9x minus y. Alright? So, let's see. Our answer is going to be option letter C. Okay? So, what is this? Number 12 is C. Okay, now let's move along to question 13. It says for all x not equal to 4, which of the following is equivalent to the expression below? X squared plus 12x plus 32 over x plus 4. So to do this, you just simply factor the top, the numerator. Okay? So I'm going to factor this using the x game. So x squared plus 12x plus 32. I use the AC method. AC and then B. AC is 32 here, and then B is 12. Okay? The two numbers that multiply to give you 32, and now to give you 12 is 8 and 4. Okay, I'm going to plug that in the center. We have x squared plus 8x plus 4x plus 32. Break it down the center, and then we can factor by grouping, alright? So if I take out an x, I'll have x plus 8. And then for this, I'll take out a 4, and I'll left with x plus 8. Factor out these two x's since they're common. This x plus 8 and x plus 8 into 1, x plus 8 times x plus 4. Okay? So that's for the numerator. So the numerator can be rewritten as x plus 8 times x plus 4 divided by x plus 4. Okay? And if you want to reduce, this x plus 4 is cancelled out. So this one goes here 1, and that goes here 1. Your final answer is going to be x plus 8. Alright, there you have it. Okay, so that tells me that my solution to question 13 is B. Alright, answer is B. Alright, moving along to question 14. It says, which of the following is a simplified expression of 9 minus x squared divided by x minus 3 for all x less than negative 3. Alright. Alright, so first of all, we can rewrite the numerator in standard form for polynomials. So I can rewrite that as negative x squared plus 9 divided by x minus 3. Okay? Now, if I want to write this as a difference of squares, I have to factor out a minus from the numerator. So this one I can write it as negative parenthesis x squared minus 9 divided by x minus 3. Alright? So anytime you factor out a minus, all the signs change. Alright? So I factored out a minus here. You notice this one became a positive and this became a negative. Alright? Why did I do that? Well, I want to use this formula a squared minus b squared factors into a plus b times a minus b. Okay? It's convenient to use this formula of the first term is positive and the second is negative. So we have that here. Alright? So to find a and b, all I just do is I take the square roots of the first one and the last one, and then I add and subtract the square roots. Okay? So I'm going to have negative x plus 3 times x minus 3, and divide the whole thing by x minus 3. Okay? So that's just applying the difference of squares formula that I wrote up there to this, the numerator, and you have this. Now you just cancel, common factor this and this reduce. So your final answer is negative quantity x plus 3. Okay? When you look at the options, they're all expanded, right? So let's just we just distribute the negative to x plus 3 to get our final result. So let's go ahead and do that. So distribute a negative to the x and then a negative to the 3. So the answer is going to be negative x minus 3. Answer is for number 14 is E. Okay? Yeah. Alright, moving along, question 15. It says, what is the slope of the line with the equation 2x plus 3y plus 6 equals 0? There are two ways you can do this. Method 1 is kind of advanced. Method 1 requires you to know the formulation of this equation and a special formula, okay? This formula applies to only standard form. Even if an equation is written in standard form, It could be ax plus by equals c, or it could also be ax plus by plus c equals 0. It doesn't really matter as long as the x and the y is on the same side of the equation. If you have this, the equation in standard form such as this, the slope m is simply negative a over b. Okay? So applying that idea here, we can see that a is 2 and b is 3. Okay? So a is 2 and b is 3. So that simply tells us that the slope m is going to be negative 2 over 3. End of story, your answer is D. Alright? Okay, so this requires you identifying the correct form of the equation and knowing this formula. If you don't know the form and you don't know, you forget the formula, you can do it the long way. Method 2, I'm going to show you right now. Method 2 requires putting the equation in this form y equals mx plus b. The slope-intercept form, everybody knows this form, y equals mx plus b. So if I can put this equation in that form, then the coefficient of x will be my slope, yes? All right, let's go ahead and do it. So we have 2x plus 3y plus 6 equals 0. The goal is to isolate y and extract the coefficient of x as a result of that, okay? So to accomplish that, I need to move 2x and 6 to the other side, so subtract 2x and subtract 6 from both sides. Minus 2x minus 6 minus 6. Alright, so let's work that out. Minus 2x minus 6. So we're going to have 3y equals negative 2x minus 6. Divide everything by 3 to isolate y. Divide by 3, divide by 3, divide by 3. And then you're going to end up with y equals negative 2/3 x minus 2. Alright? So if you take a look at this, the slope m, be careful here, this is the slope, the coefficient of x, negative 2/3, okay? Some people might pick negative 2 and select C as the answer, which is wrong. So the slope is m, because y equals mx plus b. Let me put that up here. If you write y equals mx plus b, the coefficient of x, which is negative 2/3, is your m, okay? So your slope is negative 2/3. Alright, so there you have it. Okay, last but not the least, it says the point negative 4 is in the standard xy coordinate plane. What must be the coordinates of point B so that the line x equals 2 is the perpendicular bisector of AB. Alright, so the best way to solve a problem like this is to graph the points and use the symmetry of your graph to determine where the point that satisfies the requirement will be, okay? So I'm going to attempt to draw point negative 4, 1 first, point A. So point A is negative 4, 1, so we're going to go 1, 2, 3, 4. So that's negative 4, and then we go up 1. Negative 4, 1, this is point A. Okay? Alright. We also know that the line x equals 2 is a perpendicular bisector. So where on earth is the line x equals 2? Remember that your y line is horizontal, goes side to side, and your x goes up and down. Okay, the x equation is up and down. Your y-axis is the equation of the line x equals 0. Your x-axis is the line with the equation y equals 0. Alright, so keep that in mind. So since we have x, we're going to be going up and down with undefined slope. Alright, so to graph that, we just look for 2 on the x-axis, 1, 2. And then we're going to draw the line of the graph x equals 2, which is something like this. Alright, so that line is the line x equals 2. Alright, so this is the perpendicular bisector of this segment AB. The distance from this line to this point has to be equivalent to the distance from this line to point B. Alright, so how far is A from the line? Just simply count the units. 1, 2, 3, 4, 5, 6. So since line A is 6 units to the left, so let me indicate that. So distance from here all the way to there is 6 units. In order to find out where line B is, since this is a bisector, I need to count 6 units to the right, okay? So let's go ahead and count 6 units to the right. Starting from 2, this is 2. 1, 2, 3, 4, 5, 6. If it counts from 2 to 6 units to the right, it's going to be 2, 3, 4, 5, 6, 7, 8. So this will be 8 and 1 unit up, so that it's collinear with this line right here, okay? Remember, it's a perpendicular bisector. If it is a perpendicular bisector, then it must intersect at 90 degrees, right? That means that this line must be horizontal since this line is vertical, okay? Because the perpendicular line to all vertical lines are horizontal. Alright, so we have that 90 degrees here, and this length right here is congruent to this length right here, because this whole piece is 8 units. All the way to here is 8 units. And this piece right here, I'm sorry, it's not 8, it's 6. It's 6 units actually. 6 units to the right. And then the other one there is 6 units. Okay? So using this construct, what are the coordinates of this point right here? Point B. It's simply 8 units to the right and 1 unit up, because this is 1.1 on your y-axis. Okay? So the coordinates of this point is 8, 1. Alright? So your answer is E. So there goes your perpendicular bisector. This is a line with equation x equals 2. And this is a segment that satisfies the requirement of this line being the perpendicular bisector. Alright? So that's it. So thanks so much for watching this video. Please subscribe to my channels for future updates on cool math videos such as this. You can share this with your friends also. And you can also request for videos down here on the comment section. More videos can be found on math.sir.com. Thanks again and have a wonderful day.